Okay, so besides this sorting as well as duplicate elimination operators, another example we can study based on a similar algorithm here is called grouping. We have shown this example is operated before already with the one-parse algorithm, if you still remember. We can denote this grouping as gamma city and some price on a relation. And for this relation, it includes a city as well as house price inside city, right? And this operator focuses on partition this relation or data tuples in the relation into some subgroups according to a city involved in the relations. And we group all the cities into different groups. And for each group inside, all the tuples inside this group, we have the same city as well. And we want to calculate the sum of price of the house price inside of each city, which will be the target for this operator. We devise a relation according to city and we sum the price of houses inside each city. So, this operator can be implemented in a very similar way as the previous pages on both sorting as well as duplicate elimination. And so we can sort based on city, right? Given a relation, we can sort all the tuples inside it according to the cities. And then we can compute the sum price for each of the groups. So we also have two steps, right? So for step 1, we can load the data from the disk and we can sort according to the city in each block of in the memory for the data. And then we can first store the result to the disk again. Each block will be sorted according to the city already, right? As to step 2, we can first load the data from the memory and we can merge this n-1 block simultaneously. However, here we will merge according to the city, right? And at the same time, we can also compute the sum price of all houses inside each city according to the tuples we have. So, during the merging process, we can compute the sum price at the same time, right? So we can see the algorithm we implement as grouping will be very similar to the algorithm we used before. The general cost will be also about 3BR, right? And we also have an assumption here that BR is not greater than M squared, which will be how to use this two-parse algorithm to deal with the grouping, this operator. And you can compare this operator with two-parse algorithm versus this one-parse algorithm, if you still remember, right? For the one-parse algorithm, the general cost for the grouping will be about B, right? Which is very different. Here we have 3BR because we have to read the data multiple times, which will be more costly than the one-parse algorithm instead. And its requirements for the memory size is also different, right? For the one-parse algorithm, for the memory size, we assume the minimal M will be about B, right? However, here for this minimal M, it will be about square root of BR, right, instead, which will be very different. In other words, for the two-parse algorithm, we will have a much smaller size memory to deal with the larger size of data tables. However, it will be much more costly than a one-parse algorithm instead. And you can compare them with the one-parse algorithm, so you can study them at the same time, and you can have a deep understanding for the one-parse versus two-parse algorithm as we show here. Alright, so next we will get further to show you two other operators we can start with the two-parse algorithm. The first one is the binary operator, and the second one is the join operator.